record this. Yeah, and so this is our assignment, and this is where things get a little bit interesting is when we get down to question number 15. And I'm assuming that based on our discussion last time, that everybody can do all of the questions up until number 15 with no problem. Does anybody have a question about numbers 1 through 14?
Could you do one of the questions from 1 through 14 just so we know if we understand it or get it?
Well, you mean you haven't already solved some of them and checked on your answers in Ignifium?
No,
Why?
because I have other classes that have homework due by Thursday. I have to,
This is the
figure out
most
my timing.
this is the most important class, Sonica, in your whole career.
My finance degree would
This
beg
is
to
it. This is number one.
differ.
Anyway, let's just show how easy. You could be my lead on this one because these questions are so easy that you should be able to carve out 20 minutes to do a couple of them to make sure you know how to do it.
Okay.
Even if you're doing it at midnight, because they're that easy. Okay, so we'll just do number 1. Okay, Sonica,
Yep.
and so okay, well, we'll all do number 1 together, and you guys, Sonica's our lead. We'll do Sonica and Dat. You guys can be our lead on number 1, and I'll give you 5 minutes to do it because it's really like you guys don't even need 5 minutes. I don't even think. And we'll go from there. Okay. So as soon as remember, like our protocol, as soon as you guys, girls, whoever, as soon as you get it done, then go ahead and put in chat that you've done it. Okay, and I will. So if we focus on this part of the coefficient, and I'm going to go back and I'll talk about this stuff one more time just to be clear. So then we would have I'll put so this is going to be D2 and over D2 times D1.
Mm-hmm.
And now I have to add another parentheses. And I'll change this one to a square bracket. So and this is D1 times D2 over D1. Okay. So you see what I did? And then we end up in the end when we simplify this coefficient that's in front of MCJ, that simplifies to D1 plus D2 over D1 times D2. So that looks simple, right?
Yeah.
So now I'm going to go ahead and substitute it here. Okay.
So you'd substitute for 1 over D1 plus 1 over D2?
Yep.
Okay.
So Okay, so does that look good?
Yeah.
Yeah. So now finally, right, we have to solve this for MCJ, but we have everything kind of organized the way that we'd like it.
Mm-hmm.
So we're in pretty good shape. So I'm just gonna write MCJ is equal to, and then notice we had the negative in front of the constant term, so that's going to become a positive. So I'll have
Wait, how will it be a positive? Wouldn't it
because
be?
now I'm moving everything back over so I can get QJ by itself.
But wouldn't oh yeah, I get what you're saying. Never mind. I got
So
it.
I'm adding this to both sides.
Yeah, just trying to make sense of what's on the screen. But yeah, I get what you're saying because you're supposed to add it to each side or subtract it to
Yeah,
yeah.
yeah. So if I add it to this side, it goes away from that side and ends up on the
Mm-hmm.
other side as a positive
Yeah.
number, right? Um, and I didn't do everything yet, but I'm gonna finish up in just a second. So
Mm-hmm.
so hopefully this is starting to make sense. So then I have the plus QJ part, but the coefficient now, what I should do right is if I multiply both sides of this equation by the reciprocal of this fraction,
Yeah.
then that will change to 1, right? And I'll end up with the reciprocal over here. So what that means is that the coefficient here, which is going to end up being the slope of our joint marginal cost function, which is what
D1
we really
times
want.
D2.
Yes, so it's going to be and let's d1 times d2
Mm-hmm.
divided by d1 plus d2, and um, and I would just about say voila, right? Like it's done. The only thing is, remember what we didn't do, and this is what I meant by way of finishing up, is we didn't also multiply,
It there.
yeah, right, like that.
Yeah.
Now, this probably looks a little bit yucky, like the first part.
Mm-hmm.
And I know that's yucky is a technical term in math, right? But it can be simplified too, and and if you go through the algebra and you simplify it, because again you have here d1 d2, so you're looking for common denominators. You'll find out that, and I'll let you all do it, but you'll find out, and we could like talk about it in a minute, but you'll find out that this simplifies too. Um, so yeah, so it's not like as bad as it looks. Okay, so this is our joint marginal cost function, and which is what we wanted. And our joint marginal cost function has intercept term. It's linear, and there's our coefficient in terms of the parameters when we have two firms. Okay, but there's one other thing that needs to be said, and that is what we actually did is, and now I want to, erase this. Notice where I have the highlighter, right?
Yeah.
The highlighter part of the joint marginal cost function is just the equation for factory 2. But what we did is we actually inverted the linear equations for the marginal cost of factory 1 and for the marginal cost of factory 2.
Yeah.
Notice that we only draw the marginal cost functions in the positive quadrant of the Cartesian plane. So these linear equations, they continue on over into these other quadrants.
Uh-huh.
And when we're inverting them, we're inverting the whole lines. Okay. So um, we have to be sort of careful,
Mm-hmm.
and I'm going to delete that because what we actually did, and let me try to use one other color that's maybe a good color. We're going to use yellow. Okay. What we actually did is we found a line that's the combination of those two lines, and um, and it lies right towards that. Hopefully, I'm trying to get these lined up exactly right,
Mm-hmm.
um, so you can see that we actually found a line not that stops at that particular blue point, but one that includes the line segment that we've labeled as joint marginal cost, and then runs through the vertical axis
Mm-hmm.
at some particular level. Now, I know exactly what that level is, right?
Yeah.
Because it's that intercept.
Mm-hmm.
But for joint production, we don't really want this intercept, right? We want to go here. So um, that's why I say it's subtle, and you got to be really careful when you solve these problems, because if you think once you've found um, this equation you're done, you're not quite right, because what you found is you found the yellow line, but what you really need is you need this red highlighted part that goes down here.
Yeah.
Do you see what I mean?
Mm-hmm.
So now we can go ahead and go. I'm gonna um, stop sharing. So just to recap, what we did really quickly is we're looking for the joint marginal cost function, which is this red highlighted portion. It's the beginning part of it is the segment of production from the marginal cost of the low cost factory, which in this case is factory 2, up to the point when the marginal cost of factory 2 is equal to the lowest marginal cost of factory 1. And then
Mm-hmm.
once both of the factories have the same marginal costs for each unit, then we want to get this combined um, marginal cost, the joint marginal cost function, which is the remainder of what I've labeled as joint marginal cost with a little asterisk. And those two line segments together are the joint marginal cost function. And in order to do that, algebraically, to get the equation for the joint marginal cost function, we inverted the marginal costs for both of the firms. And then we used these two conditions to define the joint marginal cost function, which is the joint output will combine the output from the two factories or two firms, and that the firms on that red segment where they're both producing, they will have the same marginal cost for each unit of output. So we did our first inversion generally there, and then we did it um, for each of the equations up here. So we solved for Q1 and then Q2, and then we added Q1 and Q2 together to get our joint output, and then we
Yeah.
added what we had here on the right side. And then once we got those, remember the steps are invert, add, and then invert
Yeah.
again. So now we're inverting again to actually get a linear equation that we can put on the same graph, which is our yellow line here. Okay.
So what we have right now is the yellow line, not the red line or the red highlighted portion.
Yeah. So what we solved for, and I'll let me select this and delete it,
Mm-hmm.
and and I'll even delete the yellow one for a minute. So what we solved for was that yellow line, but that yellow line, remember, it is the red line, but only for output levels above. And I could, let's label this, you know, Q, let's put a tilde on it. The red line is only that piece of the yellow line that's for outputs greater than Q tilde, right?
Mm-hmm.
But what we actually have is we have this linear equation, and notice how the red line segment, it doesn't have any vertical intercept, right? It just ends. But what we solved for was the whole line, and I don't know if I'm trying to get it to lay right over the top, but do you see what I mean, Sonica?
Yeah.
So we have a linear equation, and we have a vertical intercept um, here, right?
Yeah.
So so the question is like, well, what is this vertical intercept doing? How do we interpret this? Well, this is just a line, just like um, these marginal cost functions here are lines, right? But
Mm-hmm.
for these lines, we're only graphing for positive output levels, but they're lines. So you know what I mean by the Cartesian plane, right? The Cartesian plane is where we have X and Y, and you can get, negative values of X, right? Does that
Yeah.
make sense? Yeah. So generally a line is defined, as going through, like, let's say, uh, you know, there's your line. It goes off into infinity. Or there's your line there. It goes off into infinity. But in economics, because we're only interested in positive output and positive prices and stuff like that in most cases, we just only graph the portion um, that's over here, and this is called the first quadrant.
Mm-hmm.
You know what I mean?
Yeah.
So so um, yeah, this joint marginal cost function, it should be labeled with an asterisk too, because the yellow line, which it corresponds to, isn't really the joint marginal cost function. The
Mm-hmm.
joint marginal cost function is, we had it in red. It's there on the low cost factor, and then once we get to Q tilde, then it's there.
Mm-hmm.
So does that make sense? It may be
Kind
it may be complicated, but
Yeah, I'm just trying to, I'm just still kind of confused how you take the formula that we have right now
mhm.
to make it into the expression or formula we need for the highlighted red portion. Like, I'm just still kind of confused. Like, I'm still taking in.
Yeah. Okay. So that's a different question, right?
Yeah.
So long as you know that right now what we have is we have the yellow line, and
Yeah.
portion of that is the red line we need. The other bit is for factory two, we already know what its equation is.
Oh, so we
So
would use that?
yeah, so I don't know if you've, I mean, I know you have seen these because I saw them in like ninth grade algebra, they're called piecewise functions, right?
Yeah.
So I'll put a little asterisk on that one because it's not quite the joint marginal cost function. It's the yellow line, okay? But the true joint marginal cost function, MCJ,
Mm-hmm.
it is this, and I wish I had a bigger, but I'll say it's like this. Okay, it's this it's defined by two segments. Okay,
Yeah.
and so one of them is, I think we said that MC2 was the low cost factory, right?
Mm-hmm.
So for MC2, it's let's say C2 um, um, plus D2, um, and then I'll just say QJ. Okay, and this applies for I'll take that off for a minute, for uh, Q less than our Q tilde in the graph.
So it wouldn't be less than equal to?
Well, actually, it could be either one, but notice it
Yeah.
doesn't really matter, right?
Okay.
Because at that point they're equal,
Mm-hmm.
right? And then the remainder of it is going to be our MCJ star equation,
Yeah.
okay? And that's going to apply for Q, and here, if you want to, we'll do greater than or equal to Q tilde, okay?
Yeah.
So this is the true joint marginal cost formula. But
Mm-hmm.
the first part of it's really easy, right? Because it's just given to us. It's just the low cost factory equation.
Yeah.
It's only the yellow line that's difficult to get. You have to do the invert, add, and invert again.
Yeah.
Okay. So I hope I'm not boring you. You sound like you can
No,
go to
no,
sleep.
no. I just slept kind of late yesterday.
I know. Me too. I had a hard time getting up this morning. Okay. So anyway, so let's go back. We'll do I'm gonna stop sharing, and then um we'll go back to Ignatium. Okay. So now that we have that formula, so you see why I didn't actually use the numbers, because if I had used actual numbers, we wouldn't have been able to see the relationships between the parameters of the equations to kind of develop a formula that we could use to solve problems, or like on the exam, we would have been, you know, um, stuck every time going through all the steps of inverting, which you
Yeah.
can, but but um, but I prefer to do it generally, and then if you have to do it in a specific case or it's easier, that's fine. So it says, what's the cartel's joint marginal cost function when both firms are producing? So they're talking about that portion where Q is greater than Q tilde, right?
Yeah.
So in this case, we would have to go ahead and do that. So I'll tell you what, let's do number 15, and I will be back in just a minute.
So
Okay.
it's essentially just solving for it by inputting what the variables actually are.
Yep.
Okay.
Yeah. Or like I said, when you have the actual numbers, I don't know. You could like use the formulas if you want. I'm not going to discourage you from doing that. But
Mm.
if you like want to kind of, since you're just doing it the first couple times, like check your work like both ways by go ahead and inverting, and then simplifying and adding. Now that you have numbers and a calculator, you'll find out it's pretty easy, because even though the algebra for us was complicated,
Uh-huh.
that's because we were carrying around all the symbols.
Yeah.
But here, like inverting the first one, right? So all I got to do is MC minus 31 divided by 2 on both sides, and I got
Yeah.
Q1, right? And then so I'll have 31 divided by 2, which I know is 15.5. And then my 1 over D1 is going to be 0.5. So like you see, it's going to be pretty quick. So
Mhm.
so you do it however you want, but I will come back. I have it's 9:12. I'm gonna get a cup of coffee, but I'll be right here. So as
I
soon
have a
as,
question.
yeah, Dat, go ahead.
So during the test, do you want us to just plug in the formula or solve it?
It doesn't really matter as long as you document your work. You know
Okay,
what I mean?
cool.
So if you all like memorize or have the formula written down and you use it, that's fine. Yeah.
Okay,
There's
I
gonna
got
be
it.
plenty of other things for you to solve.
Yeah, yeah.
That if you want to memorize a formula is okay for this one. Okay, so let's see. Hey Derek, are you still here? Did you come back? No. Okay. Um, are- okay. So Tanish, are you here? Okay. How about you, Daniel? Daniel Groom.
What?
Who's talking? Is that Daniel?
Yeah.
Yeah. Hey, Daniel. So we're doing number 15. So I'll put you on deck for number 15. Okay. You and Sonica. I'll be back in like 3 minutes. Okay.
Oof.
Oof. You can ask Sonica questions while I'm doing this if you want. That's okay. You guys can work together, and if you guys want to chat. All right. Um, so I'm going to do that. I'll be back in just a Okay. Sonica, how you doing?
I think I have the answer.
Okay. And what about you, Daniel? How you doing?
I'm certain I don't have an answer.
You don't. Okay. Well, maybe I don't know. Is there something going to help you out with, Daniel? Is there a reason why you don't have the answer? Or was it there's something you didn't follow on what we were talking about? Or you there?
I'm just trying to figure out some math stuffs.
Oh, okay. Okay. So if is there something I can help you with right now, or are you like just need a little bit of time on your own?
I just need a bit of time on my own for this.
Okay, well, I would encourage you to go back and watch this lecture when I posted. The other lectures I posted have this material too, so like whichever one you like better. But um, I think that like we did a nice job of this. Just remember to do this stuff. Um, if you get stuck, you've got to invert the equations and then add them, and then do the replacements for some of the names of some of the variables, and then invert it again. If that's the process. If you're not inverting, adding, and inverting, then you're not going to get the right answer. So, but as you go back and you look at the video, then you'll see what I'm talking about. Okay. So what did you come up with, Sonica?
I got 4/3 or 1.33. Okay.
Yay, Sonica. See, it's simpler than you think, right? It's not
Yeah.
not that bad. But
Mhm.
and let's look at these other questions. Okay. What is the intercept of the cartel's joint marginal cost function?
Would it be 44?
Ah. Now think about this.
Because
You're talking about MC star. I mean, like the MCJ with the star on it, right?
no, just
Remember,
MCJ. I solved the whole thing,
look,
but I just
remember
don't.
the low cost firm, right?
Oh, I see. Okay.
Ta-da.
Yeah, I get what
Right?
you're saying. Yeah, it's the
Yeah, because in the beginning, they're the only ones that are producing, right? So that intercept only applies for the yellow line, right? And the part of that line, the line segment is the red line, is where they're both producing. So in terms of the cartel's joint marginal cost function, it's just where the low cost factory is producing.
So it wouldn't be for like you. Okay. So, oh, I guess what. Oh, sorry about that. I understand what you're saying. Yeah, we only solved for MCJ star. I just realized.
Yeah,
Yeah.
yeah, and that's fine. But and you're probably going to need that information in a minute.
Yeah.
You just don't need it right now. So let's look at number 17 then. So you understand like
Why
it's 16, right?
Yeah, because the
17.
original is MC. The first part of it is MC1, so it would start at 31, and then at Q whatever that
tilde.
yeah, tilde, whatever that is, you'd
Then
start
we
with
switch
MC
over.
squared. I mean,
Yeah.
okay.
Yeah. Then we switch over. And we still don't know what Q tilde is yet. Not that we couldn't solve for it, but
That's 17, right? Or
uh,
something.
well, I don't know. Let's see. It says, consider a monopoly cartel with two firms, blah, blah, blah,
Oh, sorry, no,
blah.
that would be.
How much output will the cartel produce? So this is where things get a little bit interesting. Okay. And there's only one way to do this. And so I will show you. So, okay. So I'm going to stop sharing here. And go back to the whiteboard. Okay. So now that we've gone through all of this work, now we have to go, and I'll go back to the drawing part of it. We could do this algebraically too, but which we're going to, but I think it's easier to see with the illustration. Okay. So, remember that we're looking for profit maximization. So ultimately what we're trying to figure out is where we're trying to figure out at which Q marginal cost is equal to marginal revenue. All right, because that's going to tell us that we're maximizing our profits, right? You with me, Seneca? By the way, I have to say thank you very much for coming along with me on this little journey, because it's helpful for me, and I think probably the other students, and hopefully for you, to like walk through this, because if we don't, then I can talk and then at the end of the day, maybe nobody understands what's going on.
Yeah.
So remember, there's our demand, right? And then we're gonna have, because this is just a monopolist, right? And then we're gonna have marginal revenue.
Yeah.
Right? And so I'm gonna go ahead and just, so we know that marginal revenue is green, I'm gonna write it green over there, okay?
Mm-hmm.
And for the time being, I'm gonna go ahead and ditch the demand function, because we don't really need it for anything right now.
Mm-hmm.
Okay, so, but the challenge, hopefully, what you can see is that we have, and since we've done it in red before, we have this joint marginal cost function that's like this, right?
Mm-hmm.
And then we have the part that you solve for, where we have our, right?
Yeah.
So the way I've drawn it with the two piecewise linear segments, this actually is the true joint marginal cost function.
Yeah.
It's not just the J star part. But the problem, right? The problem is that we don't know if the marginal revenue is going to cross over here, where both factories would be producing, or it's going to cross over here, where just the low cost factory is going to be producing. You see what I mean?
Yeah.
We don't know. So what you have to do is, and I'll put the little rule over here, okay?
Mm-hmm.
Yeah, I'm gonna try to write it down. Okay, to solve for cartel Q1, solve MC equals, or sorry, MR equals MCJ. Now look what I'm putting here, star. So the
Yeah.
yellow line, solve that one. And
So the second one in the piecewise function.
yeah, and then solve MR equals MC, and I'm gonna put, Ignithium will switch between the MC1 and being low cost and the MC2 being low cost.
Yeah.
I've seen that. So I'm just going to put MC low.
Okay.
Okay. So you solve both of those. Okay.
Mhm.
And whichever gives more output is the cartel's Q star, meaning
So in this situation, we can't
profit.
automatically assume that the second one, the MC low, would be not the cartel's profit max.
No, it happens. It happens on some Ignition problems. It just depends. I've seen it both ways. This is why we have to do it this way. So
Yeah.
what I want to do right now is I want to point out like why this rule works. And in order, so we have two different types of equilibria, and so what I'm going to do is, remember, so the low cost factor I was using a purple line for before.
Yeah.
So I'm going to go ahead and dump this line segment, and I'm going to dump this one, and I'm going to replace it with our MCJ star. And I'm going to replace the other one with our MCL. Okay, and I'm going to draw them both like that. Okay. Okay. So, and then I'll try to point out the solutions so you can hopefully make sense of them. So you can see where Q tilde is. I'm gonna just write it down here. Q, where's my tilde? That's where they cross, and okay. And I don't want to clutter up the diagram too much, but just to be clear, I'll use the same thing that we did before, which we had a blue dot there. Okay, so that's where our Q tilde is. That's where they cross, right? So note that we could have one type of, try to just grab the corner here. We'd have one type of equilibrium like this one, okay? But notice that if we have that type of equilibrium where we're just going to be producing at the low cost firm, and maybe I should, or the low cost factory. So I'm going to call this MC low, right? If we have that kind, then notice that the MC low line and the marginal revenue line cross at a Q that's greater than the MCJ star and the marginal revenue, right? So again, if I do this and I calculate the Q where MCJ star and MCJ low cross, and I get the MCJ low gives me a greater Q, right? Whichever gives more output, then that's the cartel solution for that type of equilibrium. And I'm going to explain why in just a minute, but just to get the idea mathematically what's going on. And now over here, if I have this type of equilibrium, now look, they've reversed, right? Now where MC low crosses the marginal revenue is at a lower output, right? Than where MCJ star, the equation that we solved for, crosses it.
Yeah.
And then that's the cartel equilibrium because it's higher. So in one case, MC low will be the right answer. In the other case, the MCJ will be the right answer.
It just depends on where the MR
Crosses.
is.
Yeah,
So
exactly.
essentially, when we're solving for this, are we looking for where MR is highest, essentially? Or
Well,
are they
I don't
equal?
know. I don't know what you mean by MR is highest. All I'm looking for is I'm looking at, if I solve these equations, remember when I solve for MR is equal to MC whatever, I'll be getting a particular level of output Q.
Oh, sorry. I mean, are we solving for Q, like where we get Q? We're looking for which one produces the highest Q?
Yeah,
Okay.
right.
Yeah, I'm just looking at my notes and looking at like I remember they gave us a MR, and then we also just already have the functions for MCJ. So I'm just trying to
Right,
figure
right.
that.
Yeah. So and that's the whole point is you're gonna have to do two
Different ones.
yeah, two different MR equals MC, and then
Yeah.
figure out whichever one gives you the highest Q. Now, by way of explanation, right, this makes perfect sense. I mean, it's just us kind of like figuring out the algebra to identify what we see on the graph. But basically, what we're saying here is if the level of output that the firm is going to be producing based on its marginal revenue equation, right, is going to be less than Q tilde, then sure, it's just going to be producing at one of its factories, right? But if the demand for its product is really high and so its marginal revenue is really high, then it's going to be better off, right? By meaning better off in terms of maximizing more profit by shifting some of the production burden to what we call the high cost factory, because it's burned through its high productivity, low cost portion of that low cost factory. It's driven up the marginal cost through diminishing returns, through diminishing marginal productivity, such that it needs to really utilize both factories in order to keep its production costs as low as possible. And so over here, you see that, yeah, it'll follow along using both factories in order to keep its cost as low as possible. If it focused on just the low cost factory, and I put that in quotes because it's low cost in the sense that it's got a lower, intercept, which is like its beginning cost of production, and it has a smaller slope coefficient. So, if you're going to compare it unit for unit, it's always going to be having a lower cost of production than the high cost firm. But if you allow this mixture of some units a different number at one of the factories than the other one, then you can begin to exploit the diminishing marginal productivity. So you actually, if you concentrated all of your production at just the low cost one, your costs would actually be higher at high levels of output, meaning higher than Q tilde. So once you get beyond Q tilde, then you want to focus dividing your output between the two factories in order to keep your costs low. And this is exactly what the algebra is telling us. It's telling us hey, if I have the type of equilibrium, let's call it a low output equilibrium, then I'll concentrate all of my production at the low cost factory.
Yeah.
But if I'm going to get high levels of output, then in order to keep my costs low, I'm going to have to shift some of the production to the higher cost factory because it's still going to be lower cost than producing all the units at the low cost factory. Anyway, hopefully that makes sense, but the algebra and the diagrams are all telling us the same thing. But in order to distinguish between these two types of equilibria, the high output equilibrium, the low output equilibrium, we have to actually do the work of comparing, okay, which of these two production strategies, focusing on just the low cost factory or sharing production between the low cost and the high cost factory, which one's going to generate more output for a lower cost. So anyway, hopefully that makes sense, but that's what we're doing. So are there any questions about that, Sonika?
No, I think it makes sense. Just solving for MR equals MCJ star and then MR equals MC low and seeing whichever gives more output would be the
Will give you
cartel's
output. Yeah, that's right.
profit max. Okay.
Yeah. And so now if we go back to the Ignithium question, now we see, oh, okay, yeah, okay, we got to find MCJ star like we did, and then we've got to find the marginal revenue, which is easy because it's going to be 187 minus 12Q. So that's part's easy. And then we got to, solve the two the two sets of equations. Marginal revenue equals the marginal cost for the low, and then for the joint
plus 2Q.
Yeah, exactly.
And then MCJ, which I already found, was 44 plus 4 over 3 QJ. So that would be the second
one. Yeah, exactly.
Okay.
And
then I guess,
so we have 4 minutes left. So I'm going to show you these answers, and you can write them down. They'll be here on the video because I should be recording. Yeah. So and then so you can check your work and see.
Yeah. So for 18, it says, will firm 1 produce as part of the cartel? You would essentially it would be what you did for 17, right? It would be 187 minus 12 QB equals 31 plus 2Q.
Yeah. So what I want to point out here, and this is, we're getting a little bit into the weeds, so we can figure out what this should be based on what we told you, that method that we just went through for comparing the two equilibria. But so how much will firm 1, we'll see in this case, firm 1 is the low cost firm.
Yeah.
If it turns out that it's the only one producing, those should be the same.
Yeah.
Right. But see, it's off by 0.2. So this makes me wonder if this is just rounding error, or if we're actually, this is probably in this case, it's a close call. We're either like right near Q tilde, or you see what I'm saying? We're right at the boundary there. So maybe firm 2 is actually producing a tiny bit, but we can't really know until we do the comparison that you and I just talked about.
Yeah.
But if these two numbers were the same, then that means we're in the low output equilibrium. But in general, yeah, they would be different. And we didn't really talk, and so I should mention it quickly, about how do you know how much output each one of the firms is going to produce. And so let me go really quickly back to our whiteboard. So you can see the whiteboard, right?
Yeah, it's just really zoomed in.
Okay, how about that? Is that fine?
That's good.
Okay. And I want to. Okay. So one of the things to notice, and I'm gonna do the high output equilibrium because that's the one we're really talking about. See the high output equilibrium. Remember that the equilibrium is, and what's a good? I'll do a red dot. The equilibrium is here. Okay.
Yeah.
Where the marginal revenue is crossing the joint marginal cost function. Okay. So that's going to give me and you could think about this different ways, okay, but this is the way that I think is the most straightforward to think about it. That's going to give me an equilibrium level of marginal revenue for the firms. Once I have the particular level of output, and I'll just call that, again, this is the high output equilibrium. So I can take QJ star once I find my quantity, and I can plug it back into the marginal revenue curve, right, equation, and I can get a number, a marginal revenue that both of the firms are getting for their output, right?
Yeah.
Well, for both of those firms, the marginal revenue is going to be the same. So if I go ahead and I'm just going to draw this really quickly because we're low on time.
Yeah.
If I look at, there's our high cost and here's our low cost firm, right? If I look at that level of marginal revenue, and I'll label this as MR star, it's some number, right? So
Yeah.
I'm just drawing it as a horizontal line. Well, both of those firms are going to have their marginal costs equal to marginal revenue, where marginal revenue is given by that equilibrium level of marginal revenue that we just solved for.
Yeah.
Okay. So I can use that marginal revenue and the marginal cost for each of the function, each of the firms and their cost functions to find, in this case, the quantity, and I'll just put it down that way for each of them. Okay. So,
Yeah.
and I'll just label this as Q1 star, and this one is Q2 star, though I don't know which is Q1 and which is Q2 right now. It's just the two firms. And those two quantities will add up to our QJ star. So it'll be pretty easy is the point. Once you have QJ star, you can find MR star. Once you have MR star, then you can set it equal to the marginal costs for each of the firms, and you can find their respective levels of output, and it should equal the total. Does that make sense?
Yeah.
So let's go ahead and stop sharing for a minute. And all I want to do to finish up, in case we have any questions. So how much will firm 2 produce? So we've done for firm 1, for firm 2, and how much profit will firm 2 earn as part of the cartel. And then it says, assume there's fixed cost of 100. Well, you know, profit is just total revenue minus total cost, right? And so remember that your total cost is your variable cost plus your fixed cost. Your total revenue, once you have your output, the only thing we didn't do is find the cartel's price, but it's the same as the monopoly price, right? So once you have their level of output, you just go up to the demand curve to find the monopolist's price. On our diagram, we took the demand curve off, but it's the same as a regular monopoly. So if you can find the monopoly price up here, you can find the monopoly price there. You can calculate total revenue. And then just remember total cost, the variable cost component is the area below the marginal cost function for each of the firms, right? So you have variable costs and fixed costs and total revenue, and you're fine. I'm gonna go ahead and reveal that. It says minus 100. So that means that in this example, firm 2 is not supposed to be producing anything, okay?
Yeah, that's what I was gonna ask. Firm 2 is gonna be 0, right? Yeah.
Yeah, in this example.
In this scenario, yeah.
Yeah, this example, you guys get another one. Okay, so it's 9:47. I'm going to